Yeah. All right, so we are officially starting our trig unit, which is the entire unit three. Unit three is 6 sections long, so they're gonna go really quick because they're chunked. Okay. This first unit in 3A is only 3 sections. Okay. There's 3A.1, 3A.2, and 3A.3. It's a very short section of this unit. Okay. Huh? No. We don't have enough time. If we were a year-round school, then we would have time for it, but we don't have time for unit four. All right, so we will be able to construct graphs of periodic relationships based on a verbal representation. Okay. So here we go. Vocabulary. Important vocabulary for us today is a periodic relationship between two variables occurs when the output values demonstrate a repeating pattern over successive equal intervals. So key things here is that we have repeating patterns. Repeating patterns and its successive equal length intervals. Okay, equal length. The period of a periodic function is the length of the x values that it takes for the function to complete one cycle. Okay, the period is the time it takes to complete one cycle. Okay. All right, so let's dive in. We're going to start easy. All right, with example one, the function f is periodic with a period of 4. A portion of the graph is shown below. So because it's a period of 4, that's telling us that this pattern repeats every 4 units. Does that make sense? So our period is 4. So every 4 units, this pattern repeats. So if I'm here at -1, -1 plus 4 means that this is the pattern that's going to stop at 3. Do we see that? Okay, so that's 1, and then it keeps going. So could we create the remaining 2 to fill in this table? Yes, we can. So let's go ahead and we're going to plot next. So continuing this pattern, the best way to think about it is every 4 units, you're moving those points, right? So if this is where it ended, then my next one's going to start 4 units later, correct? So I'm here. I'm going to go 1, 2, 3, 4. That's the next one, right? This one ended here. I'm going to go 1, 2, 3, 4. It's going to go there. This one ended here. 1, 2, 3, 4. And then this point ended here. 1, 2, 3, 4. Because the pattern repeats every 4. Do we see that? Okay, so that's 1. And then I'm going to do it again because it says to do 2 additional periods. So starting again, we were here. 1, 2, 3, 4. We're here. 1, 2, 3, 4. Then I'm going to go over 4 again, and then 4 again. 1, 2, 3, 4. And again, pretend that those are super straight lines. You see where we were going with this, right? Yeah. So far, do we have a good understanding of a periodic motion and what a period represents? We're moving each one of the points that starts the pattern. So notice that our pattern started here, right? Boom, boom, boom. And it says that it comes every 4 units, right? The period is 4. So I'm taking this point and it went 1, 2, 3, 4. So this would be the start of the next pattern. And then it keeps going. And then another start of the next pattern. And then it keeps going and going and going. Yeah? All right, so this is the baseline. Are we good at baseline? Okay, let's keep going. All right, next, a portion of the graph of the periodic function g is shown above, or in your case, it's above, but on mine is right here. What is the least possible value of the period of g? So this is where you're trying to figure out when does the pattern repeat, okay? What is the pattern? When does it repeat? How long is it, okay? When, where, and how long? That's what you're asking yourself, okay? So when is the pattern? When does it start? Where does it end? How long does it take? When does it start? Where does it end? How long does it take? Which one do you think? You told me. Well, X determines your starting. So like So you think it starts at your X? So you think it starts here? Well, if it starts here, where is this going to end? When does it start repeating? Like, what is this whole? So August said that we are doing this. Is that carrying all the way through? Okay, so then when it says, what is the least possible value? That's asking how long is it? So what is your period for G? How long does it take for that pattern? 5. So our period equals 5. Yes? You see it? So we went from, so we started here at -2 and it stops at 3. Literally, how many units apart are -2 and 3? Huh? Typically let T be time. Unless it's like, but right now we're just describing what is the period. Yeah. Okay. Can we keep going up? How we feel? So here's the pattern. I didn't tell you the period. Can you find the pattern? Identify the period. Okay. The fun thing here is that what August identified as his pattern may not be yours. But guess what? The period is going to be the same. Okay. So I could have said that mine was from here to here. Right? And it's still going to be how many units? 5 units. Okay. It's just you choosing what is the pattern that you see happen periodically. But the period is going to be the same for everybody. Yeah? Okay. All right. So example 3, using the same graph, we're going to talk about making predictions further along. Okay. So we only have a glimpse of from -2 to 9, right? From -2 to 9 is all we have a glimpse of. What if I wanted to figure out G of 14? Like the value of 14. How could I figure that out? Or what if I wanted to find G of 72 or G of -17? Which X value am I using to help me get there? Okay. So I want you to take a moment and I want you at your groups to figure out, all right, without drawing this all the way out, using what I have, how can I figure out the value of G of any number? Okay, of any input. All right. Without drawing it out. So mathematically, using what I have. All right. Let's talk about it. So remember I told you as you're doing this to keep in mind your period. So the period for this model is 5, right? That means that every 5 units, this pattern is repeating itself, right? So when you're trying to find something greater than what I can see, I have to figure out how much over my pattern is it. Does that make sense? Like how far from my starting point? So for me, I'm going to use my starting point of my pattern starting from 0. Okay. So my pattern is actually going to be this guy. All right. So I'm calculating from 0 how many times this repeats, right? So 14, first thing I'm going to do is divide. So I'm going to take the X value that's given and divide by my period. Does that make sense? Because that's how many times the pattern will repeat. Yes? So the first thing I'm going to do is 14 divided by my period, which is 5. So this pattern is going to repeat 2 times, right? After I do that, that's what I'm going to subtract. Because I'm going to have 2 with a remainder of what? Y'all remember R? Remainder of what?
Remainder of
4, right? It's 2 with the remainder of 4. Remainder is important. That remainder is the number of units you count from your starting. And that's the equivalent value. Okay? So the remainder is the number of units. I count from my starting. So I'm going to count how many units from where I started. 4, and that would be the value, its output. So I'm going to go over here. So from 0, that's 1, 2, 3, 4. And what is the output at that value? 7. So this equals 7. The remainder is the number of units that I'm going to count. Because my pattern is going to keep repeating, right? So again, let's try that theory again. So step one, I'm going to take 72 and divide it by 5. 72 divided by 5 is what? 14 with the remainder of, we want our R. We want to go back to third grade. What's our R? Our remainder is 2. Yes.
Why is our why is the remainder of 4 calculated 2.8?
Because 2 times 5 is 10. So my remaining units is 4. 2.8, 8/10 is 4 out of 5. Mhm. So my remainder here is 2. So I'm going to count 2 units from the start. So when I count 2 units from the start, so I'm here, 1, 2. What is the output here? It's going to be 6. My output is my Y value. What's my output? 6. Yeah? How we feel? Doable? Not terrible, right? It is terrible. She's dramatic. All right. Let's go the other way. Let's see how it works with a negative. So I want you to pause. I'm going to pause. Okay. What we get here? So we get -3 with a remainder of 2. So we're going to see if our hypothesis would work. Does that make sense? So this is how we're going to learn. So now, if we count it from where we are, 2 units, what do we end up with? That's if we went that way, right? We're going to go backwards. I wanted you to figure it out. I want to give you the answer yet.
I said you go
Just see what happened. What happened when you went positive? Did it work? No. Okay. Because it's a negative, instead of us going left, instead of us going right, we actually had to go what? Left. The negatives are, so we're going to count how many units? 2 units left. So when we go 2 units left, 1, 2, that puts us at -2. But what's the output? It's going to be 7. I knew you gave us the hard. I didn't. I gave you one to make you think. You didn't sound confident. You didn't sound confident. You got to be confident what you're telling me. All right. How do we feel about the patterns? Huh? I do not have any more pencils. I will get more eventually, but I don't have. I think all my pencils are gone. And my personal ones are gone too. I had a whole pack on my desk and they're gone. So all right, so we are now analyzing table. We because we are ending a little later, we'll take our quiz on Wednesday instead. And so we'll make sure we finish this on
Friday. Or when